Hello, everyone. Welcome to our 7th in our masterclass series. This particular series is around design excellence, and I just appreciate you coming again today. Thanks for spending your half an hour lunch with us here at Lunch with Larry. Today's topic is going to be in and around electrical design. So we're going to get into another technical topic, which is very exciting for me. I'm looking forward to having the discussion with you. Just so you know, I always put up my slide here for contact. So if you get to a place where you can't get a hold of us in any way, shape, or form, this is all my contact information: cell phone, email address, LinkedIn accounts, whatever. So feel free to give me a call or contact me if you have some questions, either about this session or Siemens or our series in general. So it's clear, we have this QR code. I'm putting up the QR. We have one more session in this series. You're probably already registered for that, but I'm going to start putting up the QR code for our next series, which is operational excellence. Very excited. I think our first meeting in this series is going to be an interview with the FDA. So I'm really excited about that. So hopefully you'll sign up for that series and get involved. So if you go ahead and use your application for your picture application and get the QR code, that'll take you directly to the website to get registered. So look forward to you coming to that series as well. Just wanted to touch on our ventilator project. The data that we're going to talk about today is all based around our ventilator project. This is an open source, Medtronic has an open source ventilator design that we've built into a cross-platform suite. And all of the design and discussion that we're going to have today is based around this. And we'll have a roundup here next week to talk about kind of where we're at on this overall ventilator project and all the different work that's been done. So I look forward to having that discussion next week. The value discussion, I'd like to just touch on this. When we talk about design excellence, we talk about really 3 values. This particular one is also centered around productivity. So really this is world-class design tools. And today, our Mentor Graphics Suite is the discussion that we're going to have specifically around the Expedition tool. And what we're going to do is build out a CPU board as part of this discussion and show you kind of how that would be done in conjunction with the rest of the system. The other values are really speed or integration of those design tools. We'll talk a little bit about speed today as well with the ECAD and MCAD integration. We're going to have a discussion later about quality and complexity management. How do we manage the data models, but essentially we want to get to a place where we're communicating how these tools can be used together in the digital enterprise to really provide this design innovation that we're trying to get out of our design excellence discussion. So just to center up on our value that we're trying to discuss today. So to dive into this topic, I'm going to start it with our systems modeling diagram. So our model-based systems engineering, we talked about this 2 sessions ago, and we built out this systems model, and the purpose of the systems model is really to give us a set of functions. So the export or the deliverable from the systems model is a set of functions that drive our design activities. And so here's the model that we built out. This is the systems view of that model, and that systems view has a set of functions. Now what we do is we decompose that systems view into a logical and then a physical representation of the product. And what I have here is a physical representation. Now, one of the discussions we had before is we can segment this model and we can allocate the model to particular disciplines or subsystems. So what this is a view model that's a physical view that describes the functions that are going to have to be accomplished by the electrical design. And so you can see we have a CPU PCBA. So this is the piece of the design. We have a CPU PCA right here. Oops, sorry. And these are the functions that are going to be allocated. Now those functions then get replicated into the requirements management solution, and the requirements management then decomposes this function into the different things that the electrical engineers are going to have to provide for us. So I just wanted to start out the conversation. How do we drive the electrical engineers from our systems model? And this is how it's done. So, but today the topic is really about electrical engineering, so I want to get off this as quickly as possible. So as I start to switch here, Ben, I was just hoping maybe what you could do is take over the presentation, and I'm going to go ahead and switch it to you. And what I'd like you to do is show how the schematic would be created and synchronized with the PLM system. So if you could do that and help everyone understand how this schematic is created, and of course the CPU board is the topic of discussion of the day. So if you go ahead and get started, I'd sure appreciate it.
Okay, hi everybody. My name is Ben Dahlstrom. I'm an application engineer with Mentor's PCB products. Sorry?
Yeah, and I'm sorry. It's just I've totally messed up in that the three people that we're going to have talk today is Ben, who's an electrical engineer, Gary Gorman, who is our mechanical designer, and Mark Dally, who is also an electrical engineer, is going to handle the last piece. So maybe all could introduce yourselves and give a set of background. So I'm sorry I messed up that part. If you wouldn't mind, go ahead and do that.
Yeah, no problem. I'm an application engineer. This is Ben talking, and I focus on Mentor's PCB products for design and analysis of the printed circuit boards.
Hello, my name is Gary Gorman. I'm an NX solutions consultant with Siemens. I focus on NX, our NX design suite, and printed PCB exchange tools.
Hi, and I'm Mark Deely. I'm also with the Mentor side of the Siemens house, and I focus like Ben does on all of the PCB tools.
Go ahead, Ben. Sorry about that.
I'll jump into the creation of the schematic. So the schematic I'm about to show you fits into this larger ventilator design. And when you start a schematic, the first place you need to look into is the creation of a library. Every schematic, you place down components, and those components typically have a logical definition, which is this symbol here. And then they have a physical representation, which is a cell or footprint. Creation of these parts can be a very time-consuming process, but luckily, Mentor has a collaboration with DigiKey called PartQuest. And PartQuest is a huge repository, over 1 million parts, just available for a free download for all of Mentor's printed circuit board tools. So in PartQuest, I'm going to look for a 10K resistor. It has a simple search mechanism there. It'll take a second to load. And when you get this resistor, you'll get several results, and you may have to filter down those results. And so what I'll do, I'll go and look for resistors. I have over 1 million matches. Let's do surface mount. And you can narrow down this result until you find a part that matches the design intent. So I'll even look for something like resistance, make sure I only have 10K in here. And the list goes on. And once you get this narrowed down, you can just drag and drop it directly into the schematic. So here's a 10 kilo ohm. Let me get it precise. And I'll keep this list going. And I'll apply that filter. And you can see once it loads that you can filter on several more items, more so than just that resistance. If you wanted to do power, or if you're looking for a certain package type, you could grab those. So I'll jump into Mentor's schematic capture tool called CX Designer or Expedition Designer. So here I have a schematic. It has all these parts placed and they're connected with nets. But let's say I didn't have a part and I didn't want to go through the process of making it. What I can do is just drag and drop from PartQuest right into the schematic here. So I'll drag this part, drop it there, and it'll take a second to download. And once it's complete, it'll be ready to place in the schematic. So that could be a huge time saving, just having a library already made for you. So I have this part that just was downloaded. You get a preview of the symbol and cell, and I can go ahead and place that part immediately in the schematic. And it's ready to use. And the nice part is you'll get all this parametric information along with the part when you download it from PartQuest. So if you wanted to know the height of the part, the footprint, the IPC standards, you'll get all of that included. Once you place the parts, the next part of capturing a schematic is just connecting them through nets. And I'll create a connection there. Once that net's complete, what you can do is do a net list, which is tools package. Go in and create the net list, and that will give you a representation that you can carry over to a blank circuit board where the parts will be ready to place. And I'll move over to Gary to show you how those parts are placed and how the initial MCAD ECAD setup will start. So Gary, I'm going to share the screen with you for a second here.
Okay.
And I can see your ventilator now. So
Okay,
good
great. Okay, well, here's our ventilator. Now we're in NX, Siemens Design Tool Suite. And as you notice across the top, we've got a lot of tools in our PCB exchange tasks that allow us to define a board, define components, define attributes about the boards, and then also do all of our translation and sharing of data with our IDX tools here in the middle. So what I have is our ventilator, and let's take a look inside of it. And you'll see that the board is placed in here. So for this example, we're going to start the board definition in MCAD because I've got a lot going on, so I know where the board has to sit, how big it needs to be, and where the mounting holes are. So I've defined that all right inside of NX. I can look at the board itself into my PCBA navigator. I can see I have a board, I have outlines, I have components on it, so it is ready to go. Let's switch over to just the board just so we can see a little bit easier on it. And so here's the basic board that I have. And so I'm ready to go ahead and turn this over to Mark. So I'm going to do a baseline IDX. So I'm going to export a current baseline. And we have a shared directory that Mark and I are using, and it's going to be baseline 01. And I'm going to send that right now. So I'm going to go ahead and create this baseline for Mark and put that out there on our shared drive. And with our IDX collaborator, we're both kept in sync the whole time as we do this. So we're just incrementally changing this design. We're never just wholesaling the whole data. We're just increment as we go. So Mark, I'm going to turn it over to you. So I'm going to change you to presenter, and you are ready to go. Gotcha.
Okay, so as the PCB designer, I've got the information that Ben showed from the schematic, and it's open in a very simple empty board, just a very small template. If you have your own common templates, board outlines, stack ups that you need, you can define those as templates. But as you saw from Gary's ventilator, the board is going to be very specific to where it needs to go. So in this case, I know I want to grab data from Gary. From a layout point of view, I can actually go through and you can see all the components are in here from what Ben packaged and sent over to me. I can just grab a component, place it in 3D, and it comes up in the traditional 2D layout tool. I can move them around in either side to make sure I've got them in places that I know. So if Gary wasn't ready for the board outline yet, I could carry on here doing placement, editing the outlines if I needed to. But since I know Gary's got the information, I'm going to go into the expedition side of the collaborator tool. And you'll notice that Gary published that baseline. It's now showing up in the shared space. So again, as part of the Siemens family, if we, in the setup area, we have the NX advanced features set up, so I can create models. If I have a model that I've loaded that Gary doesn't have yet, I can export them natively so that Gary can manage those in Team Center. I can turn them off if my process says, hey, I never generate models from the electrical side. The other thing I can also do is I can filter depending on where I am in the design. So early on the design, we only want to send back common things like board elements, so the board outline, obviously. We can also do rigid flex, so where we have a bend in 3D, where we have bend radiuses, those can be sent back and forth to NX as well. So we want to send the board elements, the components. Early on in the design, we probably don't care about copper yet, but we can do that later if there's needs for mechanical to do interference checks to any of the copper coming from the layout. And then obviously things like keep outs. And then depending on where you do your documentation, you can also send things like silkscreen, solder mask, user layers, assembly layers. So as you evolve the design, you can send different details. In this case, I just want to pull in the data that Gary sent me. So if I click on the baseline, because it's blue, it says it hasn't been processed yet. Here's the stuff that Gary's trying to send me. I can filter out additions, deletions, modifications. As soon as I turn off the additions, you can see everything goes away, which makes sense because Gary's sending me stuff for the first time. If I click on the board outline, I can even do a preview and saying, show me what the changes are going to be. So it's going from my minimal a simple template to the actual board outline that Gary's sending me. So that all looks good. I just want to go and take that and bring in the data from Gary, so it'll read the outline and any of the critical components Gary's already got placed. So you can see now I've got the physical board outlines, mounting holes with all their clearances, the connectors, and the robust 3D model. So a full 3D model coming in from the layout tool. So I can do checks and placement views within the 3D environment within Expedition. So now I'm just going to kind of pretend I'm doing my design. In this case, I'm going to do a placement. And I've got a pre-placed design that has all of the components placed, including all the models in the library. So in this case, I just read in the data, and you can see I've got placement set up on top and bottom of the board, and it's pulling in all of the 3D models. And again, if you look at the bottom side, in the ventilator, I've got a number of pumps and pressure sensors that are pulling in directly from the shared library. And if we look at the model mapping, you can see that all of the data is in the library. So the full 3D model, the components are all in the library that can be managed by Teamcenter and shared directly with Gary. Now at this point in my design, I've got all my placement done. I actually want to share that placement back with Gary. And I'm going to accidentally maybe move a connector. And you notice as I move the connector in 3D, it highlights when I've got physical clashes. And this is really just to show the kind of response that Gary can look at when I send it. So now back to the collaborator, I'm going to send Gary over the information for placement. So I just do a refresh. Because I've already processed the baseline, it says I'm ready for more changes. It knows that the next phase I want to propose the changes. So in this case, I'm going to tell Gary placement is complete. And I can actually see what's being previewed that's going to be sent over still. Turn that off if I don't need to see that, and then just send the response or the proposal. So now it says the proposal sent. Now Gary can review it, and I can carry on doing my normal place and route. So Gary, I'll hand it back to you.
Okay.
And we see you again.
Oh, great. Okay. So I've been working away on my ventilator design, but I'm going to come over and check my collaboration history here, which gives me a nice update of what's going on and what Mark's sending me, so I can select that. And it shows me here what I've processed before and also what's coming into me right now. So I can click on this, and I'm going to say go ahead and import that proposal from Mark. And it's going to bring in that proposal file. And what it gives me is a very nice listing of everything that's coming in. So do we have board changes, components, areas, or holes? We can look at every aspect of the board and components that are coming across. I can see there's a lot of new things coming, which I expect, but I can also just cruise down here and I see, oh, we've got a modification that Mark did. So we can select that modification, and we can see that the connector highlights. So we want to see what Mark's proposing for that connector. So I can come in here and say, preview my changes. And what it's going to do is it's going to show me a preview, a simplified preview of all the components coming across. And you'll also notice that there's a blue box sitting next to the actual component that's in blue also. And what that does is that shows me what Mark has done with that connector. So I can look at that and make a decision on whether I can accept that change or reject that change. And when I do that, you'll notice down here in my dialog that there is going to be a response file sent back to Mark. And that response file is going to give him all the information that I either accepted or rejected. So our preview is just about done building here. So that's our preview. And really, I can't accept that. I got too much going on in my design. So I need to tell Mark that can't be, I can't take that. And what I have is the capability right here to say reject it. So I'm going to reject that. Then I'm going to say okay to this. And now it's going to go ahead and populate the board with the very detailed components that Mark sent over from his library. And you'll see the connector moved back into place here. And it's populating the board for me with all the detailed components. And some other aspects, as Mark mentioned, while this is moving along here, is even in NX, with the NX and Expedition connection now, we have the capability to send NX 3D models back over to the Expedition side. So an example of that might be if I design a RF shield on a board, we can pass that 3D data back and forth. We can even pass information if Mark were to create the obstruct outline of where this RF shield had to be. I can take those curves right into NX, use his curves, not recreate or have to try to redraw them, and place those use those curves to build my shield. Go ahead and use my 3D tools in NX to build that shield. And then I can actually send that shield back to Mark. So he's going to be able to see everything that's going on around his board. So we're wrapping up here. It's got a few components more to load. And again, there's quite a few components coming across on this board. We see a little bit of a lag when we're doing it over a web presentation too. So, but you can see the very nice detailed components that I have coming into NX.
So Gary, while that's loading, we may want to talk a little bit about just the single source of truth for the models going back and forth, like you said. So on the Expedition side, you saw we had all of the 3D models available. Those are native into NX, so that we are actually sharing the same 3D model library, and that can be managed as well in Team Center, so that you're managing one single set of models for both the electrical and the mechanical side of the tools.
Yeah, one nice part about that is that you don't have to align those models twice across the MCAD and ECAD domains, which that's just a huge time saver.
Yep, we have one version of the truth. And again, just to reiterate this is, I'm just bringing in an update to Mark. Nothing's happened to my board. It hasn't done a replace on my board or my connectors. It's just bringing in all the new data that Mark sent me. And you can see up in the top, we have this big set of tools in the PCB Exchange on the NX side for managing all these boards. If we start from left to right, those are all the attributes I can assign in the MCAD world for the board. You know, what is the board outline? What are board keep outs, keep ins, drilled holes? So now we're starting to talk the same language when we talk from ECAD to MCAD. If we move over again to that middle area where the IDX area is, we've got import baselines, export baselines, and then we got a collaboration history. The three little icons next to that are, I can do incremental updates. And then that's where Mark actually talked about, we can actually bring in that copper. So now we're not gonna have time to show that today, but we can actually bring in the copper traces and in the MCAD world, show them on the board. So now our board is in here.
Go ahead, sorry.
Yep. So one of our boards in here now, and I'm complete. So right now I am in complete sync with Mark. And also just remember that it sent a response file back to Mark. So I'm going to turn it over to Mark so he can see what that response file does for him. So I'll go ahead and change you to presenter, Mark, if I can find my mouse here. And yes.
And there we go. So I should be back.
Yep.
So you notice again in the collaborator tool, I can just pop that up and you can see the response file here is in blue. If I simply click on that, I can see all of the changes or the review that Gary did on it. Again, if I go and filter on the ad, it comes down to, oh, wait a minute, everything was accepted except something in here. So if I again go down underneath, I can expand it open. Oh, he didn't like something I did with the connector. Is that the one connector? Again, I can do the preview on it. So if I've got a very large, dense design, I can quickly find out, okay, that was the only thing Gary didn't like. Okay, I get it. Maybe I moved it accidentally. Maybe we had a chat and it's kind of, yep, we'll put the connector back. So again, the response file says, don't move the connector. I don't have to remember where it was. I just apply the response and you see it push the connector back to where it was. And in here with the whole collaboration history, I've got a baseline, a proposal associated with that baseline, and a response to that proposal. Now, as Gary and I evolve the design, if I was to move another component, maybe need to do some more component updates. I've moved one component. I refresh, and it says if I've got additions, deletions, modifications, as I do incrementally, it's showing the next proposal going to go back to Gary is only one component. So again, I can just say this is an updated placement and send that proposal. And you can see the structure again. This proposal 01 is still part of that first baseline. So we can continue to do this iteration as the design evolves on both sides and have that traceability and history of everything that was done and synchronized in one database.
Sure. Mark, maybe you could comment on specific problems that designers have with this process so that folks can have a better sense of, you know, what is this really fixing? What are the problems that designers have that this interface between the ECAD and MCAD fix?
Sure, Larry. There's two really main issues that customers face that the Siemens Mentor partnership kind of addresses. First is, who has the latest updates? In most current environments, our customers tell us it's very hard to keep track of who has the latest version of the updates. It was the last update done by Gary in MCAD, by me in ECAD, and typically most of this is done via filed shares or shared files over email or a random folder that people put up in the network. And then, did Gary get the latest board outline on the shared folder that Ben and I just talked about an hour ago? That's a very hard thing to keep track of for all of our customers. As you saw with this whole collaboration history, everything is integrated into the database. You get notifications, you know when the last update was done. So first part of it is just gives you that control over when the data is there. You can get the right data at the right time to the other person or other people that are involved in your collaboration team. Secondly,
Sure.
there's a single source of truth on all the CAD models. In most environments, you have to manage two libraries, and that's always a challenge. As you saw here, we were sending models back and forth. Nowhere did either of us open a model. Nowhere did we do any alignments. How many times have you ever had a connector alignment or misalign from MCAD to ECAD? That's a very common problem. Mentor will help you align those automatically based on the expedition footprint, and then it's automatically shared, correctly aligned, and correctly oriented to the mechanical side. So these two aspects help you minimize the errors, prevent any missed changes, and allows you to get a higher quality design in a shorter time.
Sure. Any thoughts on how this drives simulation once we get this all together, both in the ECAD, MCAD integration?
So in the simulation side, again, from the Mentor side, all of this information in the electrical domain, you can launch simulation tools for signal integrity, power integrity, creepage rules, things like that for safety. And on the Siemens side, you can launch, again, take that same design data that we passed from ECAD to MCAD, and then those MCAD tools can go into things like SimCenter, launch into thermal, do any other kind of analysis that we can connect to, all integrated based on the same data set.
Sure, that sounds great. So I'm going to go ahead and we're getting to the end here. So it looks like we've used your half an hour. So I'm going to just thank you for coming to the Lunch with Larry series. Really excited to get all these different technical discussions going in the context of the ventilator model. Next series is going to be operational excellence. This is our sign up for that. Starts on the 4th of June, hoping to have the FDA as part of that first discussion. So here's the QR code for registration. Really appreciate you attending today and look forward to you being part of the next session. So thanks so much and have a great day.